Good morning. Today we present our discussion based how we understand on the topic counting techniques and probability. I am Joven Vinya, BS IT-1A. We are the group 8 IT-104. Probability. Probability is a chance of prediction of happening of an event. While working with probability, we must know about the some terms such as event, sample space, experiment like event, complementary events, and mutually exclusive events, etc. Example: toss a coin 100 times. How many heads will come up? Probability says that heads have a 1/2 chance, so we can expect 50 heads, but when we actually try it, we might get 48 heads or 55 heads or anything really, but in most cases it will be a number near 50, more at probability index. Experiments and random events. In probability theory, random experiments means a repeatable process that yields a result of an observation. In probability theory, an experiment or trial is any procedure that can be infinitely repeated and has a well-defined set of possible outcomes, known as the sample space. An experiment is said to be random if it has more than one possible outcome, and deterministic if it has only one. Example: the toss of a coin, throw of a dice, and lottery draws are all examples of random events. Certain event, impossible event. An event E is called an impossible event if P/E equals 0. This happens when no outcome of the experiment is a favorable outcome. For example, in throwing a die, the event of getting a natural number greater than 6 is an impossible event. Answer: random event process variable, an event process that is not and cannot be made exact, and consequently whose outcome cannot be predicted. The sum of the numbers on two rolled dice. Contrary events. Opposite event rule. The probability that event A happens is equal to 1 minus probability that A doesn't happen. Definition: two events are mutually exclusive when the occurrence of one prevents the occurrence of the other. Certain events, sure events, and events which is should occur at every performance of an experiment is called a certain event connected with the experiment. For example, head or tail is a certain event connected with tossing a coin. Compatible events. Incompatible events. Compatible events are two events that can occur at the same time. With incompatible events, it is impossible for both events to happen at the same time, since it is not possible for a single question to be both true and false. I can determine that these events are incompatible. Example, compatible events are events that can occur at the same time. If events A and B are incompatible, it is impossible for both A and B to happen at the same time. For instance, if you are rolling a typical die, an event A is to roll a 1, 2, or 3. An event B is to roll a 4, 5, or 6. Then events A and B are incompatible. Event implied by another event. We say that the event A implies the event B, or the event B is implied by the event A. If the occurrence of the event A means that the event B occurs as well. When throwing a die, the event A equals one of the phase 1 or 3 appears, implies the event B one of the phase 1, 2, 3, or 5 appears. Any event implies the certain event. Operations with events. We can consider the following operations between two events: union, intersection, difference, and complementary. Let's see what they mean in our example. The union of an, which is written as or A, U, B, is the event formed by all the results that satisfy our examples. Mutually exclusive events. Disjoint events are events that never occurred at the same time. These are also known as mutually exclusive events. These are often visually represented by a Venn diagram such as the below. These two events never occur together, so they are disjoint events. The set representing two incompatible events are disjoint. Sample space of an experiment. In probability theory, the sample space, also called sample description space or possibility of an experiment or random trial, is the set of all possible outcomes or results of that experiment. The elements of a sample space may be numbers, words, letters, or symbols. Example, the set of all possible outcomes is called the sample space. Thus, in the context of a random experiment, sample space is our universal set. Here are some examples of random experiments and their sample spaces. Random experiment: toss a coin. Sample space S equals head tails, or as we usually write it, HT. Equally possible events. Equally like events are events that have the same theoretical probability or likelihood of occurring. Getting a 1, 2, or 3 on the toss of a die and getting a 4, 5, or 6 on the toss of a die are equally likely events, since the probability of each event are equal. Probability of an event. The probability of an event is the number of favorable outcomes divided by the total number of outcomes possible. Converting the fraction 35 to a decimal, we should say there is a 0.6 probability of choosing a banana. This basic definition of probability assumes that all the outcomes are equally likely to occur. Example, tossing a coin and it landing on heads. Tossing a coin and it landing on tails. Rolling a 3 on a die. Rolling a number 4 on a die. It rains 2 days in a row. Drawing a card from the suit of clubs. Guessing a certain number between 000 and 999 lottery. Finding probability in events. For finding the probability in independent events, we simply multiply the probabilities. While for finding the probability of dependent events, we either find the probabilities before multiplying by good analysis or by using the conditional probability. For example, picture a fruit bowl that contains 5 pieces of fruits, 3 bananas and 2 apples. If you want to choose one piece of the fruit to eat or a snack and don't care what it is, there is a 35 probability you will choose a banana because there are 3 bananas out of the total of 5 pieces of fruits.
Independent events probability. An event which remains unaffected by previous event or set of events is known as independent event. For example, landing on heads after tossing a coin and rolling a 5 on single six-sided die. Choose a marble from the jar and landing on heads or tossing a coin. 3. Definition of probability. First, theoretical or classical definition of probability. Empirical or statistical definition of probability. Axiomatic definition of probability. First, theoretical or classic definition of probability. Let a random experiment produce only a finite number of mutually exclusive and equally like outcomes. Then the probability of an event A is defined as P open parenthesis A close parenthesis equals number of for favorable outcomes to A slash total numbers of outcomes. Theoretical probability is also known as a classical or a prior probability. Classical probability is also known as statistical probability. Example, the odds of rolling A to a fair die are 1 out of 6 or 1 and 6. That's one possible outcomes. There's only one way to roll 1 divided by the number of possible outcomes of open parenthesis 1, 2, 3, 4, 5, and 6, close parentheses. The odds of winning Powerball are 1 and 290 292 million, close parentheses. The 1 is the number of times that the event can happen. You winning divided by number of possible number combination. Open parentheses about 292 million tickets sold. The second, empirical or statistical definition of probability. Probability is also called experimental probability. Is the probability your experiment will give you certain result. For example, let's say you wanted to know the probability a person prefers cola A over cola B. You test of 100 people reveals that 75 people prefer cola A. Your probability is number of ways the things occurs. Open parenthesis 75 close parenthesis slash number of the ways the things you could possibly occur. 100 equals 75 slash 100 equals 3 and 4 or 75%. And the third, axiomatic definition of probability. A probability can define as a set a function which assign to every event a number known as the probability of E, such that the probability of an event is greater than or is equal to 0. For example, if a candidate A wins, then candidate B cannot win the election. We know that the third axiomatic of probability state that if A and B are mutually exclusive outcomes, then P open parenthesis A1 U A2 close parenthesis equals P open parenthesis A1 close parenthesis plus P open parenthesis A2 close parenthesis.
Random experiment and event. When something happens, it is said that an event has occurred. All the events are always associated to someone random experiment. Complementary events. In probability, the complement of any events is the not of that event. In a random experiment, the outcome must occur on every trial, and the probabilities of all possible events must total to 1. For example, flipping a coin is an experiment on getting a head or a tail, or two events which are associated to this experiment. Formula. The probability of event B is given by PB, and the probability of its complement by P complement B. In general, this is to remember that the total event of two complementary events is always equal to 1. That is, PB plus PB complement equals 1. Thus, the probability of complement of B is given by B complement equals to 1 minus PB. Here's an example. The probability of getting a white ball from a bag of ball is 1/4. Formula. P B complement equals 1 minus PB. Solution. P Ball is not white equals 1 minus 1 half equals 3/4. Sample space. The sample space plays a very important role in finding the probability of an event associated with a random experiment. Sample space is a term associated with probability theory. General sample space. Commonly we use union to represent universal set. Universal set. An experiment can have more than one sample space depending on the condition being set. Example, tossing a coin. When flipping a coin, two outcomes are possible, such as head and tail. Therefore, the sample space for this experiment is given as sample space S equals head H and T equals head and tail. Union events or union of events. An event is something that has happened and is always associated with an experiment. There are different operations performed on events. Union is one of them. As the name implies, union means joining of two things irrespective of their individual behavior. The union of two events give us compound event. Formula. Suppose A and B are two, two events associated with a random experiment. Then the union of A and B is represented by A union B. The probability of union of two events is given by P, the union of A and B equals PA plus PB minus PA and B. Here, PA is the probability of event A. PB is the probability of event B. Also, P, A, and B is the probability of the intersection of events A and B. When A and B are two independent or mutually exclusive events, that is, the occurrence of event A does not affect the occurrence of event B at all. In such a case, P, A and B equals 0, and hence we have P, the union of A and B equals PA plus PB. If we have more than two independent events, say A, B, and C, then in that case, the union probability is given by P, the union of A, B, and C equals to PA plus 2B plus PC. If A, B, and C are not independent or mutually exclusive, then the union probability is given by P, the union of A, B, and C equals PA plus PB plus PC minus P. I repeat, P, the union of A, B, and C equals PA plus PB plus PC minus P, A and B minus P, B and C minus P, A and C minus P, A and B and C.